You are all welcome to the second module of Ground Dispatch Initial Course, BLC 101. Our objectives for this training, BLC 101, is to describe the airplane so as to know the distinction between aircraft and airplane, stroke helicopter, know components of an airplane, know the weight limits of Boeing 737 Classic. The weight limit, we are to pay attention to the details of the data provided in this training so that we will be able to make use of and draw inference from the weights data provided. We should know the space required by Boeing 737 Classic for parking based on the data provided. We also need to know the cargo hold and compartment capacity. We need to know the volume limitation of the hold and compartment. Know the cargo hold doors limit and clearances for an item to enter. Know the airplane systems for Boeing 737 Classics and Boeing 777. All these are included in this training, but not limited to what we listed above. What is the distinction between aircraft and an airplane? To answer this question, let us look at the definition of the aircraft and the aeroplane. For anything suspended in air to stay without dropping, we should know that there is a force keeping it up there. If any object is there in the atmosphere suspended and not coming down due to the force of gravity that we all know that should be acting on it to pull it down, it means there is equal and opposite force sustaining it up there. In the case of an aircraft, it is any machine that can derive support in the atmosphere due to reactions of the air other than the reactions of the air against the earth surface. Reactions from the air in the sense that that object is lighter than air, and the air in the atmosphere, it is deriving support from that atmospheric air due to the fact that that object is lighter. In the case of the airship, the gas in it has to be compared with the atmospheric air is lighter. It has a volume, and the gas in the airship, the gas pumped into the airship is lighter. Therefore, the airship derives support from the atmosphere by lifting up, by floating on the atmospheric air. Let us look at the definition of the airplane, or if you like, aeroplane. It is a power-driven heavier than air aircraft, deriving its lift in the flight chiefly from the aerodynamic reactions on surfaces which remain fixed, like the wings, under given condition. We have examples like the Boeing 737, Boeing 777, and the like. All the aeroplanes listed above are aircraft type. We can see that in the definition for aircraft and the definition for an airplane and the definition we have for helicopter, there is the word aircraft in both of them. Suffice it to say that an aeroplane is an aircraft and helicopter is also an aircraft. Again, from those definitions, we can deduce that aircraft is a group name. It is just a group name, the name given to a group of machine. An aeroplane is a name of a member of the group referred to as aircraft. The system of definition for aircraft is designed to enable civil aviation authorities to group and regulate aircraft for administration of safe operation of aircraft. The key word, like we said here, is safety. In furtherance to ensure this, civil aviation authorities do certification for 3 major products of aviation. These products are aircraft, aircraft engines, and propellers. Let us continue the major definition, aircraft definition, based on category, class, types, classification, and wake turbulence. We've seen that majorly we can divide aircraft into 2 based on their weight compared to the weight of the air in which they want to steer in. Therefore, we have heavier than air and lighter than air aircraft. We can also divide aircraft into 2 major parts by looking at the type of wing attached to the fuselage, the type of wing of the airplane or the aircraft. For the airplane, the wing is fixed, and for the helicopter, the wing is not fixed. It rotates. So we get into classifying or dividing aircraft into fixed wing or rotary wings. Let us look at an example of lighter than aircraft. The lighter than aircraft, they are designed to have within their structure sufficient volume such that when filled with air, like I said the other time, maybe hot air, they become lighter. They become lighter than the air. For example, hydrogen or helium. They displace the surrounding ambient air and float. This is the same principle that makes corks float on water. We can behold a colorful airship that is flying over a particular stadium. This is an example of lighter than aircraft. For the heavier than aircraft, the heavier than aircraft are the ones equipped with a power source to provide thrust for lift and movement. In this area, the wing of the airplane performs a lot of tasks. The wings of the airplane makes it lift. The sophisticated heavier than aircraft are designed with heavy reliance on computers using the most modern materials. We can all attest to this, that when we look into or stay in the cockpit of any airplane, you see a lot of gadgets that have their basis of function wind to computers. An example of a heavier than aircraft is a glider. Let us look at some other examples. We have a glider and the unmanned aerial vehicle or remote pilot vehicle. They are commonly referred to as drone. We have an example here. This is a drone. Now, UAV/RPV means unmanned aerial vehicle or remote pilot vehicle. Both of them are commonly referred to as drone. We have an example here. This is a drone. This is a glider. Another example of heavier than air is our reference airplanes, the Boeing 737 and Boeing 777. Continuing the categorization of aircraft, we can also categorize an aircraft in the area of category. We can divide aircraft into aeroplane, helicopter, power lift, free balloon, glider, and airship. For class, we can have single engine land, which is airplane. We can also have an airplane that is single engine sea. We can have multi-engine land and multi-engine sea. All these are for aeroplane. We can also classify based on certification for airmen. For our reference airplane, a pilot who is desiring to fly a Boeing 737-300 will have following as certification. In the area of category, it will be an airplane. In the area of class, it will be given certification for multi-engine land. Multi-engine land. Then in the area of type and variant, it will be given the Boeing 737-300. If he is desiring to fly Boeing 737-400, when it comes to variant, it will be given Boeing 737-400. Those are the certifications. So we can also look at classification or categorization of aircraft by way of licensing. Another way we look at definition of category for airplane is based on flight operation. Airplane can be categorized as category 1, category 2, category 3. Category 3 is divided into 3. We have category 3A, category 3B, category 3C. All these categorizations are made available on the summary page of the operation specification for airlines. We can also look at this categorization of aircraft based on wake turbulence. Aircraft can be categorized as heavy when the maximum certificated takeoff weight is 136,000 kilograms or more. It can be medium when it is less than 136 but more than 7,000 kilograms. It will be light when it is 7,000 kilograms or less. Let us just get familiar with components of a simple aircraft. We have the fuselage. The fuselage are in simple airplane or even some sophisticated airplanes houses the engine, the seats for cabin, and many other components of the airplane. It is the main structure or body of the aircraft. Wing. Like I said the other time, the wing makes the airplane flies. Depending on what the manufacturer wants the airplane to do in terms of performance, these wings are designed. And those designs, they depend on a number of factors such as size, weight, use of aircraft, desired speed in flight, and at landing. For our reference airplane, this is the type of wing that we have for our reference airplane, dihedral. That is, if an horizontal line is drawn from the base of the fuselage and the wing makes an angle with horizontal, that angle is referred to as dihedral, as we have seen here. Appendages to the wing are other parts we refer to as flap, ailerons. They complement the function of lift that the wing offers to the airplane. Flaps offer or give extra lift. We also have aileron. Let us look at the component referred to as empennage. It is the tail of the airplane. There is a section that is referred to as the cone. It has a cone structure, and this empennage is made up of the elevator, the rudder. It has a vertical and horizontal stabilizer. The elevator controls the pitching moment of the airplane, and the rudder controls the yaw. This is a picture of a more complex airplane. The components we have seen in the simple one is the same here, only that there are some additional components added to enhance the functions the other ones are doing. Now let us go to the weight and balance specifics. We shall be looking at the passenger and the freighter. Aircraft weight and balance is mainly about weight limits and position where load should be placed on the airplane in reference to the specified datum. We can say that weight and balance, the aircraft weight in most cases is directly proportional to the performance of the airplane. For instance, the landing gear of an airplane has some connection with the CG of the airplane in terms of performance, and it is the strength, the reinforcement this landing gear can provide for the weight of the airplane that makes the airplane perform in the manner in which it is performing in terms of sustaining the weight when the airplane lands. Now let us do some work on getting thoroughly familiar with the weight limits, dimensions of the aircraft components pertinent to the weight and balance and load control devices. We are going to look at these data, the weight limits in kilograms and in pounds. For Boeing 737-300, we have two engines compared here. Pay attention to the weight of the airplane at takeoff, the maximum design takeoff weight. We can see for 3B1 engines, we have 56,472 kilograms as the takeoff weight, when the maximum design taxi weight is 125. Go again to look at the maximum takeoff weight when the maximum design taxi weight is 130,500. It is 58,967 kilograms. If we compare this with the 3B2 engines, CMF56, for 137,500, the weight is 62,142. For 140, the weight is 63,276. Let us look at the difference between the maximum taxi weight and the maximum design takeoff weight. The difference is just the taxi fuel, the maximum taxi fuel the airplane could, take. For landing, we have seen that the landing for the maximum design taxi weights are all the same. Attention we have to pay here is to looking at the difference between the maximum taxi weight, the design taxi weight, the maximum design takeoff weight, and the payload each of these airplanes can take. The payload is the revenue load airplane could take with those maximum takeoff weights. Now, for the first one, the maximum structural payload is 16,148. The next one has 15,028. And for the CMF to B2, they all have the same. If you look at the first two engines, you can see that the higher the maximum design taxi, the higher the payload. You also go to pay attention to the usable fuel that these airplanes could take with each of the weights. The usable fuel is also directly proportional to the weights. The usable fuel is directly proportional. 16,141 here, 17,326 here. Suffices to say, these airplanes, the higher the takeoff weight, the more fuel they could take, and that translates to more range. That is the distance they can travel with a particular quantity of fuel. For Boeing 737-400, all we just have to look at here is that their design taxi weight, maximum design takeoff weight, are larger than that of the 737. It means they could take more. When you look at their maximum structural payload too, they are also able to take more than the 737. That is just mainly the difference. Let us look at the 500 variant. For the 500 variant, their weights, their maximum taxi weight, maximum design takeoff weight are also more than those of the 300 based on the engines. So the main difference with all these airplanes are they can take more payload based on the maximum design taxi weight, and they can take more fuel. When we look at their zero fuel weights, the maximum design zero fuel weight, which is actually the opportunity for us to take load without fuel, that is when we are considering all our load without fuel, you can see the figures there. They are 46,493. For 500 variants, the payload, when we look at the maximum structural payload, we can see that it's at 15,000. So it is taking load less than the 400. Usable fuel also are almost like that of the 400, meaning the range will also be the same. Furthering on general characteristics, the picture before you on the screen right now is trying to get us dimensions, is about dimension, general dimensions we have for the 737-300, and they are for the ones with winglets and the one without winglets. When we talk about winglets, the winglet is the curvature of the wing. The picture to the left has winglet, while this one is without winglet. It's without winglet. All we need to get to know here, or we want us to get to know, is the length, the dimensions. Once you get to know the dimension or get familiar with the dimension of the length of the airplane, for instance, this 737-300 has its length to be 109 feet 7 inches. It means you can figure out a parking space, or if the airplane wants to turn at 360. Note that anytime you want this to make decisions on parking space for Boeing 737-300, there should be an addition to this distance, to this length. You should be thinking of about 20-25% of this distance added to it for it to be able to maneuver very well in the parking space. This is for 500. All you need to know is just get acquainted with the figures. The total length of this is 110 feet 7 inches, or you have it given in meters too. It is 36.40 meters. Here we have the width in terms of space, the length of the point of one wing, this and this. General ground clearances. For this picture, it covers 300, 400 and 500 variants. Make use of the letterings here, A, E, C, D, E. Make use of those letters to pick in feet the distances of the description we have here. We have the top of fuselage, we have the entry door, you have the forward cargo door, wingtip, engine, just to use it to get acquainted with the dimensions. We have the interior arrangements for the model 300 before you now. Main difference is we have the interiors that mix first class with economy, and the interior that is just all economy. The one that is all economy has two structures, two bases here. It is a single class, but when you look at the economy class, you have 149.6 in one, and in the other you have 140 seats for economy and 8 first class. The pitch for the mixed class is 32 inches. The pitch for the single class is 30. Just get to look at these two and get those dimensions. This is for 737-500. We are looking at the seats and the way they are arranged. They are 6 abreast with a single aisle. Get acquainted with the dimensions too. This is pertinent to weight and balance and load control. The variant we are talking about here, these are dimension A, aft cargo door compartment. The compartment of Boeing 737-300, we have 2 holes, and each of the holes have 2 compartments each. The forward hold has compartment 1 and 2, or you can refer to this compartment as pit 1 and 2. The aft hold is also divided into 2 compartments, compartment 3 and 4. We can also refer to them as pit 3 and 4. You need to pay attention to the variant we make as our reference here. That is 737-300, and we also have 500 there. Make use of the dimension A and B to get how long these pits or the holes are. Here we have for the 3 variants too. You can have the airplane model, you have the bulk cargo. In loading in 737-300, 400, 500 are done bulk. That is, they don't require ULD, that is unit load devices, like containers, pallets, and nets. There are restraint nets to cover up each of the compartments. Requirements such as container and pallets are not used. Here, loading is made bare, that is bulk. We are not placing them in a container, either are we placing them on pallets. We just load the items bare, and that is referred to as bulk loading. Get acquainted with the dimensions we have here to see the capacity of the hold. We also have the fuel tank capacity here. You can get the fuel tank capacity. These are issues that are pertinent to load control and weight and balance. The picture before you is just the door clearances. It will not be ideal to get to the airplane to know that a particular item will not enter through the door, although the hold has enough volume to take that item, but based on the dimension in terms of volume, the height, the length, and its width, it is good to get acquainted with this table so as to know that, oh, this item will not go through the clearance of the door. For instance, if we have an item that is more than any of the dimensions here, or it will not be able to go into that hold, even if the volume of the hold can take it. Just get acquainted with this. For 737-300 that we have in M3, and for the forward cargo hold, we can see that any item that is 36 by 49 will not go in, because the dimension here is 35 by 48. This is 777 characteristics. Also get to know on these, we have 777-300, 200 extended range, and 777-200. remember our reference is the 300. For the 300 passengers, configuration is 388,491 up to 550. You can also get the total cargo volume on this table and many other information about 737-200. You can get the maximum fuel capacity, you can get the takeoff weight, you can get the maximum range. For our reference airplane, the maximum range of the ETA is 5,845 nautical miles. For the wingspan, length of tail, height, interior, cabin width, remember Boeing 737, unlike 777, unlike the 737, has two heights. That's just the difference. We refer to the 737 as narrow body, and we refer to the 777 as wide bodied. Let us look at the holes in pictures for both 737 and 777. We shall be looking at the passenger, the combi, and the freighter. The picture before you is you seeing that although nets are used to restrain the kind of load that is in here, but they are loaded bare. They are loaded as bulk. We can also look at loadings that has to do with ULDs. Again, ULDs are unit load devices. We have the size codes of this ULD and we have the position on this airplane 777 numbered. We have position 11, 12, 13, 14, and you will have the size codes of the ULD that can fit into this position. We shall be looking at ULD in another module. We shall be looking at ULD, their description, their sizes, and the way we make load in them in another module. But for now, just get to know that loading in freighter airplanes are made by the use of ULDs like containers, pallets, and they are made up in size codes. And these size codes are K, L, and P. We have A and M. We shall deal extensively when we are talking about the ULDs and their usage for loading on wide-bodied airplane. This is another ULD, codes and position. Loading around here is done bulk. That is, it will not require a ULD like container or pallet. This is another layout for wide-bodied airplane. We have the main deck and the lower hold. Another picture of how we put in containers, pallets. This is the main deck of a 777. Let us look at how containers fit in. Okay, this loading is done on pallets. We refer to this base, this loading device, as pallets. But here we have two containers, and I will trace them for you to see. Two containers. This is a ULD that we refer to as containers. It is two in the sense that this is one and this is the second one. To take the shape, the exact shape of the fuselage of the airplane, the deck, they take up. These points are positions numbered left, right, as we have them on the layout. This is position 14 left. This is 13 right and 14 right. This is to note or know the ULD, the type of ULD that can fit into these positions. If you look at the container in here, you see that the shape is made in this format of the airplane so that it can fit in the form this airplane is made. The cabin of some airplanes are also made use to load cargo. You can see it in the picture we have here. Airlines that do this, they have procedures in their manuals to do this. We have to look into 737 and 777 systems so as to get acquainted with those systems that has to do with weight and balance and load control. It is clear and glaring to know that air systems will be pertinent to load control in the area of the holds, the cargo holds. What type of head do we have here? If you are going to load in an animal, a live animal, you should know where to put it in terms of the temperature that goes on in that cargo hold. So we shall be looking at the systems and how they are pertinent to weight and balance and load control. The systems that we have on the airplane, on both types of the airplane, the 777 and the 737, we have the airplane general, emergency equipment, doors and windows system, air system, landing gear, fuel system, flight management navigation system, flight instrument, display systems, fire protection, communication system, flight controls, electrical system, and all you have there. We need to look into these systems so as to ensure that we are acquainted, you are familiar with the systems that will demand your knowledge when you are making use of them on the airplane as a load controller or a ground dispatcher. You can look at this list and try a puzzle on your own before the next training to know which of these systems will be pertinent to load control or weight and balance. Till the next class, pay attention to the details we have in here and be ready that we shall look at few of these systems to get thoroughly familiar with them. Thank you.